We are ZAM, and this is our projectile launcher for FEDD of 2019. I'm Zack Horton.
I'm Amaya Mickles.
I'm Andrew Verdi.
And I'm Mike Pudlo.
For the ask stage of the engineering design cycle, we had to create a launcher able to shoot a projectile to target 30 feet away. There were requirements for the size, material, and systems of the launcher in our rubric. Our main obstacle was trying to make it as accurate as possible by balancing the force and the angle of the barrel. We tested it by shooting at a mock target and a brick wall. For the imagine stage of the engineering design cycle, it is important your design is actually capable of being built. We had three initial ideas: a trebuchet, a crossbow, and a compressed air launcher. We chose the compressed air launcher because it would perform better and more consistently at the FEDD competition. We made a pros and cons table to help make our decision. Continuing the imagine stage, we had to select a projectile to launch. We decided between a foam golf ball and a Nerf bullet. After making a pros and cons chart for each projectile, we selected the Nerf dart due to its more appropriate design for our DIA.
For the plan stage of the engineering design cycle, we decided for our compressed air launcher, we would build the body out of wood, use PVC pipe for the barrel, as well as the adjustable nozzle and the stand. Each member of our group designed a sample sketch of our launcher, then we came together to design the final product. This design was going to be the most effective for both the materials required and accommodate the various requirements outlined in the project guidelines. For the create stage of the engineering design cycle, we thought we would have to angle the barrel significantly and drop the weight from a maximum height in order to reach the target 30 feet away. However, after testing, it became clear that the angle would have to be 0 degrees and would only require to drop from about half the total height. For the improved stage of the engineering design cycle, after undergoing testing, our project exceeded expectations with its abilities in both accuracy and power. We determined the most consistent launching angle and height to drop the weight in order to give us the best opportunity to hit our target. The biggest change we could make in order to better achieve our goal would be to create a system for finer adjustments to the angle of the barrel. With the PVC pipe construction, we are limited to exactly how precise we can change the angle. We did test the maximum distance we could launch the projectile, and it ended up being around 40 to 50 yards.
In E101, we were asked to choose our top 3 options for FEDD projects from a variety of different projects based on personal interest. We chose the projectile launcher for a variety of reasons, including its application and reliance on basic yet useful physics, the creativity it provided with multiple ways to complete the same task, the inherent challenges that came with creating a launcher, and the competitive aspect of FEDD with competing against other teams. There were several steps we took in the building process for the launcher. First, we created a concept sketch with our initial idea. This was then expanded into more of a formal blueprint that we could put some dimensions on and get a general idea of how much material we would need. Finally, we took this and built the physical launcher using wood and PVC. Building our launcher required many different materials. The barrel assembly was entirely made of PVC, which allowed us to create a pivot point, giving us 2 degrees of freedom in order to aim the launcher. The main frame of the launcher was built entirely of boards in order to ensure structural stability. The propulsion system utilized lightweight but durable string, a 5-pound kettle bag, and a stomp rocket airbag with tubing. Finally, the design of the launcher was completed using spray paint. Here are several pictures from the design process of our launcher. On the left is a photo of the initial materials. On the right is a photo of the project during construction. And finally, the photo in the middle is a photo of our completed launcher.
Overall, we are very happy with our final design and the effort we put in. However, there are a few minor areas where we could have improved. Looking back, we decided on initial design very early on. However, we could have benefited from research and testing of other designs. We also could have performed more tests with our final launcher. We were only able to test the launcher outside, which wasn't an accurate representation of FEDD Day, which was inside. More tests would have given us a more accurate trajectory of the launcher, allowing us to refine our design. Advice for incoming freshmen. First off, don't procrastinate. This project is very time consuming and will require a lot of commitment. Secondly, don't worry if your project isn't perfect. You are graded on the process rather than the end result, so don't stress too much. Thirdly, don't assume your first design is perfect. There are many solutions for the problem you are trying to solve. Also, make sure to leave time to test your project. Lastly, and most importantly, have fun. Choose a project you're passionate about and you will become personally invested in your work. Also, make sure to include every team member because each person has something to contribute. FEDD results. We finished third place at FEDD and our launcher was very successful. Of our 3 shots, our first 2 hit the inner ring and the last one just barely missed. Only us and 2 other groups were able to hit the target from 30 feet away. Here's a video of our launcher in action on FEDD Day. This was our only shot that missed the target, but trust me, the other ones hit. This is our works cited page. Thank you for listening.